Good morning, everyone. My name is Valerie, and this summer I looked at heavy metals in the Boulder Creek Watershed, and I conducted a consumer review of at-home drinking water test kits. So I'd like to start this off by asking the audience if you would raise your hand if you would drink this water. So those of you who didn't raise your hand, obviously you make an assumption that this water is contaminated and probably unsafe to drink, but we will find out at the end of this presentation if this water is safe to drink or not. So I want to start this off by talking about heavy metals. So this is a list of heavy metals that are commonly found in polluted drinking water, and ingestion of heavy metals can negatively impact human health, and contaminated drinking water is a primary pathway of chronic exposure to toxic pollutants, especially heavy metals. So we have some sources of water pollution in the Boulder Creek watershed. Boulder and the surrounding cities has a very long history with mining, and that unfortunately means there's a lot of mining waste in the environment. We also have industry, so that's anything like transportation, construction, manufacturing, power plants. Those are all ways that heavy metals are released into the environment. We also have urbanization, which increases the need for things like mining and industry, but also increases the need for clean drinking water. So this led me to my research question for the summer, which was how much heavy metal pollution exists in the watershed, and how can I, from the perspective of the average consumer, test this water? So I had two main objectives for my research. I wanted to identify and quantify pollutants in the watershed, and I also wanted to review the different brands of drinking water test kits. So I chose these four kits from Amazon. I chose them because I thought that they would fit the scope of my project and fit my objectives with my research. Some of them are heavy metals tests, and some of them test for other parameters, and they all work by dipping the strips into a water sample, and then you look at the color, and that determines what level of pollution is in the water. So I have my map of all of the sites that I visited and sampled. So everything that's in purple is a sample site, and all of the red is a pollution source. So I tried to collect samples near those pollution sources, and I also tried to collect samples from cleaner water. So that would be like up here in the Green Lakes Valley. That's where like the alpine water is, super clean water. And then I also had some lower basin samples that are more like in urban industrialized areas. So I was really trying to go for like a widespread of the watershed. And so I had three steps to my methods. I collected my sample and I tested it with my kits. And then I compared my results from the kits to the YSI water quality probe. It's like the lab standard. And my first main result is that all four of my kits failed to detect the presence of heavy metals. So these two graphs show specific conductivity and total dissolved solids, and this is data collected by the YSI. And so on the x-axis, I have all of my sites, and each bar shows the level of pollution at those sites, and the orange ones are the highly polluted sites. So these elevated levels of specific conductivity and total dissolved solids suggest the presence of heavy metals, but these two parameters are not direct indicators of heavy metals, but they do suggest the presence of compounds with highly conductive characteristics, like metals. So some more evidence that supports this claim with the SPC and TDS is that this sample had a drastic color change as the suspended solids settled. So that suggests that there's something heavy in this water. So the kits were really difficult to interpret, which resulted in a misleading analysis of water quality. So the color pads in these kits were often discolored, they were unclear, and they would frequently bleed onto each other, which kind of muddled the results. And a lot of times they would show colors that weren't even like in the color charts to compare and interpret your results with. So statistically, each kit performed differently for the same sample. So one kit would say that a sample had a low level of pollution, and another kit would say that the same sample had a high level of pollution. And this difference can be attributed to the fact that it was very difficult to interpret my kit results. So my safe home kit was the best one out of all 4 kits tested. So this is my 5-star rating of all of my kits. And Safe Home had the most accurate measurements compared to the YSI probe. And it also had the lowest frequency of bleeding, discolored, or unrecognizable like color results. And so the Verify and Advanceable had kind of like a middle ground. They weren't great, they weren't terrible, and my J&W test was the worst one because it did not detect a single heavy metal, and it was only a heavy metals test. So are these tests safe for water quality analysis? Well, site was not a significant factor among kits. So that really means that the results didn't really differ, no matter what sample I was looking at. And so according to the kits, all these samples are safe for human consumption. And I had a pretty big diversity in where I collected my samples from, and it seems highly unlikely that all of this water is the same quality. So we're back to my picture here. So according to the kit, this water would be safe to drink. And this is just a kit that you could buy from Amazon, and it's pretty similar to whatever is like you could buy from the store, and they just don't work. So I think this becomes an issue when it's put in the context of drinking water. So this orange mine water is safe to drink according to the kits, but that is just a dangerous assumption. And these kits are one of the only accessible and affordable ways to assess water quality, but they're inadequate and they put people at risk for consuming dangerous polluted water. For my future work, I would like to collect more samples from more sites, look at more polluted sites, and I would also like to use specialized equipment to actually see what heavy metals are in each sample and compare that to what the kits say. And I would also test a wider variety of kit types. So finally, I would like to thank RECCS, especially Alicia and Carla. I would like to thank my mentor, Sammy, and I would like to thank the RECCS cohort. If anyone has any questions, I'll be taking those, and thank you for your time.
I gotta ask, you bought them on Amazon. How did your reviews compare to Amazon reviews?
A lot of the Amazon reviews were like, these kits don't work, and they don't. So it was pretty similar, yeah.
The same thing with hot tubs, so I have one at my new house.
Oh, interesting.
We see the same thing with the strips versus the liquid drop like Taylor kits. So
Mhm.
I would be interested to see how those other tests would work for your samples.
The orange gunk was coming out of the mine on top. Is that iron oxide? Is it rust? What is this stuff?
I believe it's iron. Yeah.
That looks like you'd be drinking heat.
Yeah. Not great.
Okay, thank you very much.